10 minutes. All right? That's about it. So 279, we're going to have to use the ideal gas law, and we're going to have to use the one with mass in it. And it says calculate the molar mass. So capital M equals what? Little mRT over PV. So this one's really easy because you just plug in the numbers. Okay, so this will go really fast. We got 0.116. Okay, it's in kPa, so it's 8.31. Okay, the temperature is 273 would be 350. Okay, and then the pressure is 155.3. By the way, those who had turned in the labs from other classes on the yes, ma'am.
I had 400 instead of 350.
Yeah, me too.
Okay, so I misadded then. So 400. We'll go erase that. Thank you. Sometimes I do things in my head, it doesn't work out right. So 400. Okay, and then we need volume. And so it has to be 0.025, right? I think I did that one right. If you do 250, it's not going to get, it's going to get an answer that's 1,000ths off. Okay? On that one. Okay, so the answer for that one is 279. The answer would be 99.4, right? That's what you got? 99.4 grams per mole. Make sure you write your units in there. All right. So that was number 279, correct? All right. Next one. What was the next one I gave you?
281.
281. Okay? So 281, we use our density equation. Density equals what? PM over RT. Okay, PM over RT. So this one, again, you're just plugging in numbers. Other than silicon tetrafluoride, you've got to figure out, okay, what that is. But you just add those all together. So 144.5. The molecular mass was what, 104.09? I think we did this in class, didn't we?
Yeah, we did.
I didn't do this the other classes because I recognize I gave you that in the assignment, but that's okay. It's good to look at it again. 8.31, and then your temperature on that one is 273, so that would be 345. Is that right?
Yep.
And then you got your answer, and be grams per liter is what that would be. So it would be 5.24. So we did it again. You got the right answer again. So. Okay? And this will help those who are gone too. So, all right? So that's 281. We got two more to work through real quick. What's the next one?
297.
297. Thank you. So 297 is looking for density. Well, it has density, so we've got to use that equation, density equation. So we start out looking at density equation, maybe have to rearrange it. PM over RT. So that one is looking for pressure. So pressure equals dRT over capital M. Right? So our D is 2.7. That's grams per liter. I'm going to run out of room. That's okay. I'll put it down here. Okay. R has to be, what's they wanted in? Pressure in kPa, so it's 8.31. Temperature is 293. And the molecular mass we're dealing with is neon. So what's neon? And that's not diatomic. I had some people come up, is that diatomic? At least you're thinking about diatomic, that's good. So that's 20.18. So our pressure and our answer for 297 is 326. 326 kPa. All right. Okay, and then what was the last one? 302. See, these aren't too bad. I mean, these are, as we get through all of these, I think they're going to be very helpful. So on this one, it looks like we're not given any density. We're not asked for a density. So it looks like we probably would use the PV equals little mRT over capital M. I'm just expecting that we would do that for 302. So then it's asking for what's the volume. So then volume equals little mRT over PM. Okay? So hopefully we got all those numbers. 302, we got to change kilograms into grams, so that's 8,470 grams. So that's a little wrinkle you've got to think about. If you leave it in kilograms, it's not going to work because your units aren't going to, everything has to be in grams on that one. So our R is kPa. Boy, I like using 8 kPa, which is okay, 8.31. A lot of times books will just use one particular one, so you're used to that. The temperature is going to be, I think, 313. Okay, pressure is 89.4. And then we're left with sulfur dioxide. And I think sulfur dioxide is it like 64.08? 0.06? I'll take that. That was a little bit off, but not too bad. So I think let's see. Did I write that in Kelvin? I don't think I have written so you can see it very good. So that's 313, right?
Yeah, 313.
Okay? So once you do that calculation, then for number 302, your answer should be 3,850 liters. Is that right? Because we have a lot of grams that we start out with. So, all right, good. If you got all those answers, you manipulated those equations well, and you understand them pretty well. So, good job on that. If you got those all correct.
So anytime we use a metric unit, it has to be converted to like the basic unit. Like it can't have like molar, like kilo.